Welcome to the Terrracotta Webcast series. This episode, Hadoop and in-memory, real-time big data intelligence. We'll be talking all about Hadoop and how you can share insights across the enterprise by connecting Hadoop to a real-time in-memory data platform. We'll also focus on the challenges in this kind of project, and we'll talk about how to get started. I'm Andy Raskin, Senior Director of Product Marketing at Terrracotta, and I'd like to introduce today's speaker, Manish Devgan, Terrracotta Director of Product Management. Manish runs product strategy for Big Memory, Terracotta's in-memory data platform, and he's been working with enterprises around the world who want to share Hadoop insights in real time using in-memory data management technology. How's it going, Manish?
Good, thank you, Andy.
Great. Well, before I turn it over to you, Manish, I'll just talk about the agenda today. So Manish is going to cover a very quick intro into what is Hadoop, and then talk about some of the weaknesses of Hadoop and some emerging best practices for addressing those within memory data management. He'll talk about real-time intelligence examples using Big Memory and Hadoop, and also how you can get started with in-memory data management and Hadoop. And then, of course, we'll have questions at the end. Of course, if you have any questions, just type them into the question panel in your viewing screen, and we'll get to as many as we can at the end. Also, you'll receive a link to the slides and a link to a video of this webcast in the next few days. And with that, Manish, I'll turn it over to you to talk about the power of combining Hadoop with in-memory data management.
Thanks, Andy. Thanks, everyone, for joining the webcast today. So let's quickly cover what is Hadoop. Hadoop is an open source framework widely used for data-intensive distributed applications. It's commonly used for drawing insights from large data sets. As you may know, the Hadoop work was motivated and derived from Google's MapReduce and Google File System, and then later created at Yahoo. Widely speaking, the Hadoop stack has at its core two main components. One is the HDFS, and the second one is MapReduce. HDFS, which is the Hadoop Distributed File System, provides scalable and distributed storage model. It typically is a cluster of what are called data nodes, and the data node serves up blocks of data over the network. As you know, Hadoop is designed to scale to tens of terabytes of storage and runs on top of file system of your underlying OS. The second main component of Hadoop is what is termed as MapReduce. And MapReduce is the compute engine or a framework for processing large data sets in your Hadoop cluster in a parallel and a distributed way. What happens in MapReduce layer is that it splits the processing of a task and achieves efficiencies required to complete the data analysis. So typically there are two main tasks. One is the map, which is used for filtering and sorting. And then the second is the reduce phase, where most of the assembling and summarizing of results happens. And as most of you know, there are a lot of benefits of Hadoop and the reasons why it is so successful. Some of the main ones are noted on this slide. We have seen the number of clusters expand exponentially in past few years. And that's because of the scalability which Hadoop provides. Hadoop also provides redundant storage capabilities for reliability. And as you know, the Hadoop ecosystem is very rich and flexible. There are many tools and frameworks around Hadoop components, so whether it is HDFS or MapReduce. And then Hadoop is also schema-less. You hear about that term all the time, that it can absorb any type of data from multiple sources. So that brings the flexibility in Hadoop. And most importantly, Hadoop brings massive storage and compute to commodity servers. This is why it is very popular today. The result is that there is no need of specialized hardware, and the cost per terabyte for your storage and analysis is significantly reduced. Let's talk about some of the use cases where Hadoop is used, and this is something we see in our customer base. We have seen Hadoop used in use cases like gathering insights from data to help target ads and promotion to improve, let's say, a specific campaign, or in general, increase sales, right? And we have also seen companies use data insights to prevent things like customer churn. They use sophisticated predictive modeling to predict likelihood of a customer leaving is another big use case we see. And again, some of the use case centers around recommendation engines, use of Hadoop for recommending, let's say, a particular content or influencing search results based on some of the transactions you might be doing. And we see a lot of adoption in the machine-generated data analysis. We see companies who are trying to use machine data to predict, say, which generator in the grid will likely fail sooner than others. And they are using these kind of insights to update things like maintenance schedules for equipment and things like that. Let's quickly jump into some of the weaknesses in the platform, in the Hadoop platform. There are a couple of things which bubble up in this category. There is no support for real-time insights. Hadoop and the supporting tool sets and frameworks are still catering to more of a batch-oriented usage, and the latency is still at best near real-time. It's minutes, if not sub-second insights, and that's what a lot. Yeah.
So Manish, when you're talking, I think what this means is, you talked about some of the questions that Hadoop is good at answering, like, recommending a product. So you're saying, Hadoop is great if you want to, know which, the answer to that question, say at the end of the month or the end of a quarter. But if you want to know it, right now while the transaction's happening, it's hard to do that with Hadoop. Is that right?
That's right. It's more, current use cases are centered around more batch-oriented analysis, and people are looking for that real insights, right, real-time insights. And we also see the lack of ability to perform any kind of real-time analysis, and that's what makes it impossible for people who are trying to build all these exploratory or interactive data analysis consoles, right? So we don't, the days of that traditional BI dashboards is really gone, where you had to build a summary report by slicing and dicing a particular data set. What we see users expressing a desire is for this exploratory analysis for purposes of like forecasting, right? So more along the lines of doing a what-if scenario, where you want to create a hypothesis based on the insights you gain from the facts from your data set. Right. And we also see that there's a lack in general of the tools for business analysts. There's a lack of easy-to-use analytic tools and any kind of visualization mechanisms for business analysts and data scientists who are interested in getting insights from their data. Those are some of the things which Hadoop lacks. So let's look at some of the emerging best practices we have seen in our talking to our customers, and we are seeing that customers are more and more looking for how they can combine the in-memory data management products and frameworks and bring that to Hadoop. Right. So with the availability of sophisticated in-memory data management platforms, we see a huge demand for bringing some of the advantages of in-memory storage and compute to Hadoop. So we see that, as you all know, real-time means different things to different people and systems, right? So we are seeing the need for getting insights at rate where 1 second might be too long. That's the kind of latency people are expecting for analysis. We also see that there is a line being blurred between systems that serve the traditional OLTP use cases as opposed to OLAP. So that is changing, right? There is a need to bring a lot of transactional info, information like, let's say, orders and provisioning data, and use that for analysis and gathering insights.
Hey, Manish, you mentioned that there are some use cases where like 1 second is too long. What's a use case where that's the case?
Yeah, so just take an example of when you are going to swipe your credit card, and you want to do fraud detection, and you have to come back with an answer whether the particular transaction is fraudulent or not in few seconds. So it will be maybe just 3 seconds, right, where you have to make that determination, and you're going to be handling terabytes of data to make that decision. Right. We also see new frameworks and products, things from turnkey custom solutions built on in-memory data platforms like big memory, for example. And people are also looking at alternatives to some of the core components of Hadoop HDFS. So this slide captures how we see different use cases of real-time apps like e-commerce apps or transactional apps, which typically are leveraging the in-memory data management platform. And there is a growing need where these transactional apps want to leverage insights which are coming from platforms like Hadoop and vice versa, right? We also see how the transactions which are flowing through these real-time data apps are becoming important, and there is a need for integrating and facilitating the flow of data between these two big data platforms. So that's what this slide kind of captures.
So Manish, it looks like it's a kind of, almost creating a kind of virtuous cycle where the transactions are being fed into Hadoop very quickly so that Hadoop's insights are as current as they can possibly be. And then those insights are then fed back into your in-memory data platform, big memory in this case, so that applications, transactional applications, have access to those insights as quickly as possible. Is that what you're talking about?
Yes, yes. So there is a growing need of sharing that data, bringing those insights which you have in your Hadoop cluster, bringing them and making it available to your transactional app, and then also leveraging some of the transactional data which is flowing in this in-memory data management platform and pushing that to Hadoop for maybe future analysis and processing. So I want to talk about quickly through a real-time intelligence example. And we at Terrracotta work with many customers in financial services, customers who deal with online payments and credit cards and doing fraud detection. And I want to walk through a kind of a composite use case where there is an application built on the Terrracotta Big Memory platform with a very strict SLA requirement, right? This SLA requirement, in terms of time would be, let's say, 200 milliseconds, right? So this application uses Terrracotta Big Memory, our in-memory data management platform, with terabytes, multiple terabytes of data in memory. So it also leverages insights from a very large Hadoop cluster to make that risk application more accurate. So you are basically doing a risk analysis, and you want to have those insights available to you when you're making that call, right? So some of the insights which are coming from this very large Hadoop cluster are related to things like a threat score that may help you determine if, let's say, a transaction may be a result of an identity fraud, right? So this process of bringing insights from Hadoop made use of ETL scripts, that would push MapReduce results to big memory once the processing in Hadoop was complete. And if you go to the next slide, that slide shows you how the new solution of the data integration makes use of the Hadoop to big memory connector, which we have built, that makes it possible for insights to stream as soon as they are available into big memory. So there are huge benefits here. The risk application now has access to insights as soon as the results are available from the Hadoop cluster. So let's quickly talk through how you can get started with in-memory and Hadoop. And there are some use cases which you should look out for in your enterprise, and where you should look at bringing the in-memory technologies to Hadoop. So if you're working on if you already have a Hadoop project and you see the need to have real-time access to insights or analysis from Hadoop, that's a good use case to get started. And I would say a small to medium-sized cluster where the use case is around more of exploratory and analytics, that may be another good candidate to see how you could leverage in-memory technologies with your Hadoop cluster. And also, if you're already a big memory customer and want to see how you can leverage the data flowing through your system for analytics and processing in Hadoop, that's another good use case, a good target use case for you to start looking at our offerings in the Hadoop integration space.
Well, thanks, Manish. Well, we want to open it up to the audience for questions. I'll remind you that you can ask a question at any time, and we'll take as many as we can get to. We already have a bunch. You can just type the question into the question panel or into the chat window. So the first question I have is from the audience. I use Cloudera. Can big memory work with that to do the kind of things that you're talking about?
Yes. So the connectors we are building with big memory are going to be certified by major Hadoop vendors and distributions. So we are working closely with some of the leading Hadoop distribution vendors to get these connectors certified and validated.
Great. So you mentioned a couple of use cases, but what industries are you seeing that are using this kind of in-memory technology with Hadoop?
Yeah, so Andy, I touched on the financial services use case, but besides that, we also see use cases from just e-commerce type applications where you want to influence the buying behavior of the user who's actually logged in, and base a promotion on a real-time insight which you are gaining from, let's say the historical information you have kept in your Hadoop cluster. And we are also seeing a lot of use cases coming from like machine-to-machine use cases where companies are looking for taking time series data from which are emitted by machines like spark plugs or jet engines, and trying to figure out whether there is an analysis needed, right? A quick analysis. And mostly the use cases we see in machine to machine is where they want to build these exploratory analytics where they want to test out their hypothesis, right? Figure out why the problems are happening. So they're building all these analysis on top of this memory, which is all pulled into in-memory data.
Great. So you talked about the big memory Hadoop connector, and we have a question: how hard is it to get up and running with that? Is that easy? Is it a very difficult integration? Could you talk to that?
Yeah, sure. At the end of the webcast, we'll give you a link to where you can download our connector, and also there is documentation provided along with that. And like our software, we pride ourselves with having the software easy to use, and it's just you have to simply follow the steps to install the connector, and it's pretty easy to do. So you just have to follow the instructions which are bundled with the connector.
We have a related question. So ETL processes are normally very difficult and time-consuming. So you got to do profiling, data cleansing, etc., and they're often performed in batches. Is the ETL process not needed anymore when using the Hadoop connector and loading all the data into memory?
Yeah, so we have seen use cases where people have actually replaced some of the ETL connectors and built some of the logic which sits alongside our connectors. And we have seen people being very successful in ripping and replacing the ETL custom scripts which they had, and then leveraging our connector. Alex is also on the call from our team. Alex, do you want to add anything to that?
Sure. I mean, I guess it depends on how complex your ETL process is. There's certainly advantages to using our Apple connector in particular context to streamline the process. I think the main benefit will be around performance. So if it's still a complex ETL process, there may still be some complexity that remains, but the overall performance should improve.
Thanks, Alex. By the way, that was Alex Ordesky, Director of Big Data Integration at Terrracotta. So Manish, next question. So are we basically saying that Hadoop is basically a replacement or stand-in for a traditional disk-based data store like a relational database when working with big memory?
Yeah, we have seen customers when they're dealing with unstructured data, they are replacing a lot of use cases where the standard databases were used for processing and analytics, but the standard transactional applications are still leveraging the databases. But especially for where databases were used for data warehousing and also analytics, that's what Hadoop is kind of taking a place.
Great, thanks, Manish. Well, that's all the time we have for questions today. If you'd like to get some more information and connect with Terracotta a little bit further, you can go to terracotta.org and download the Big Memory and Hadoop white paper. It's under the resources section in white papers, and it goes into a little bit more detail about some of the things that Manish has been talking about today, and particularly the Big Memory Hadoop connector. You can also download the early access release version of the Big Memory Hadoop connector, and the link is here. You can just visit terracotta.org and go to the product page for Big Memory Max, which the Hadoop connector connects to, and you can see it there. And you can also, if you'd like to further contact Manish, his email is here. And we'd love to hear how your in-memory and Hadoop projects are going, about your challenges and successes. You can post to the Big Memory Forum, which you'll find at terracotta.org, or just tweet with hashtag big_memory. In case you missed portions of this webcast, the recording of the entire event will be at terracotta.org shortly, and we'll send out an email when it's up. Thanks for your interest, and we look forward to having you join us for future episodes in the Terracotta Webcast series.